In this unit, we're going to study triangle inequality theorem. And this theorem says a triangle exists if the sum of the two smaller sides is larger than the third side. So basically, you can say A plus B is greater than C, assuming C is the largest side. So, and notice that it says a triangle exists. So the way that teachers ask questions is like the following. Is this a triangle? And you're given 3 pieces of information. You're asked to determine whether I can have a triangle or not. So let's look at these 3 numbers. Number 1, 8, 17, 24. 24 is the largest side. So I need to add the 2 shorter sides together and see if it's greater than 24 or not. And the result is yes, therefore I have a triangle. So let's look at number 2. 7 is my largest, so I add the other 2 together. I'm hoping that 6 should be greater than 7, and the answer is no. So in this case, oops, sorry, I dropped my pen. In this case, I don't have a triangle there. So you can finish the rest of it. Let's see. I'm going to do number 5, which is a little bit more tricky. And now 50 being the largest number. So, oops, sorry. So I just need to add the 2 shorter sides together. Hopefully they're greater than 50. And as it turned out, that they came out exactly to be 50. And the answer is still no, because it has to be larger. You know, larger or equal to doesn't count. It has to be larger. Okay, so pause the video and finish the rest of it in this category before we move on to the next one. So the next way that you can be asked is a question is, we can ask you to find the third side if I give you the length of 2 sides. So let's see, how do we do this? Given 2 sides of a triangle, you can set up an inequality. You can set up an inequality using the sum and difference to show the range of possible length for the third side. So what do I mean by that? So for example, in 9, I'm given 2 sides, 14 and 22, but I don't know if 22 is the largest side or 14 is the smallest side. So we can go into the proofs of this. However, for now, the easiest thing for you to do is for you to remember this. If I assume X to be the third side, regardless whether the third side being the longest or the shortest or the middle one, and I know X has to be in this range between A and B. And A is the difference between the 2 sides given. Oops, difference, not different. Difference. And B is the sum. So in other words, if I want to know my third side, I need to add the 2 numbers together. So I should have 36. On the longer end, and on the shorter end, I subtract the 2 numbers and I have 8. So I know my third side has to be somewhere in between in order for me to have a triangle. Okay, same thing with number 11. I can say that the X has to be less than the sum of 11 and 3, but greater than 8, which is the difference between 11 and 3. Let's look at number 15. If a triangle has length of 15 feet and 27 feet. Check all the possible length for the third side. So if I add the two together, I should have 2, 3, 42. If I subtract the two together, so I should have 12, right? So let's see, which means 34 works. 12 doesn't work because I have to be greater than 12. Equal doesn't count. 29 works, and does 18 works? 43 doesn't work. So I have three possibilities here. Okay, so this is how you handle this type of problems. And if you want to know more of the details, you can come and see your teachers and see how we can prove this. Ordering of angles. The angles of a triangle can be put in order by comparing the sides. The smallest angle is always opposite. Let me highlight this. Opposite is really important. The smallest angle is always the opposite of the shortest side. And the largest angle is always opposite of the, you guessed it right, longest side. So that's how we pair them up. The angle, and we went through this when we were talking about Pythagorean theorem, for example, that the hypotenuse, which is the longest side, is always opposite the 90-degree angle, the right angle. And 90-degree angle in a right angle is the largest compared to the other two, right? So, excuse me. So for the diagram on the left-hand side, the order the angles from least to the greatest should be, because it's 7 is here, so A is the smallest, angle A, and then 10 is the next, so angle C, and then angle B is the third. And by the same token, ordering sides, we order sides in the same way. The sides of a triangle can be put in order by comparing the angles. The shortest sides is always opposite of the smallest angles. That's right. And the longest side is always opposite of the largest angle. And over here, if this is 103, so this side, EF, has to be the largest. So that's the first one. And here we are not given any information, so you have to calculate that. So if you do 180 minus 103 minus 42, so what should that give you? That should be 77 minus 42. So that's the smallest angle right there on F. So DE is the shortest side because angle, that's an E, because angle F is the smallest angle, and that leaves DF being in the middle right there. Okay, so not hard at all, requires a little bit of calculation. So let's look at the first one. The first one is pretty straightforward. We have to order them from the least to the greatest. So 17, 20, 24. So 17 is facing angle M, 20 is angle P, and then it's angle N. Let me do the rest of them are pretty much the same. Let me do number 5. Order the sides from the least to, let me do number 3. Read the instruction from greatest to least. So in this case, it has to be C, angle B, and angle D. The rest of it is pretty straightforward. I'll do one more. Number 5, we have to order the sides from least to greatest. So what do I have here? If I have 31, 57, 180 minus 31 minus 57, I should have 92, right? Check my mental math. I sometimes go too quickly and I make lots of mistakes. And so if I go from the least, I have to go from 31 to 57. So that would be KL, JK, and JL. Is that right? Check my, again, check my calculation. I'm a little insecure about that. I think that's about it. The rest of them are all pretty much exactly the same. This is not a challenging unit at all. Okay, so work it through, and then we will work on Hinge theorem later. Okay, before we move on to the next theorem called Hinge theorem, I want you to think about a scenario. And here I am, here we are, we have a set of twin brothers. If you can think of anybody in the school at PHS who look exactly the same, twins, brothers or sisters. Their faces are the same, their body features are the same, and their legs are exactly the same. So at least we can say, let me use a different color, that this leg, the left legs are exactly the same, and the right legs are exactly the same. Okay? So the Hinge theorem says that if one of the brothers, and they're playing on the playground, for example, if one of the brothers, let's pick on this one on the right-hand side. By the way, apologies for this lousy graph. I cannot draw to save my life. So let's hope I can survive this. Now, this brother decided to split his leg a little further. Now, his leg hasn't grown. It's still the same, about the same length, right? So as you can tell that the left leg is still congruent and the right leg is still congruent to the right leg to his twin brother. And now let's look at the distance. This distance here and this blue line here, originally, when they were splitting the legs exactly the same way, exact same angle, these two sides should be congruent, right? That's pretty intuitive. But now, because he split his legs, one of them split his legs further. So let's call this A and B, and let's call this purple C. So we have already drew the conclusion A and B are congruent, but we can tell that A is less than C, right? A is shorter than C. C, because he split his leg bigger, the distance between his 2 feet, which is C, is much longer than the distance between his brothers, which is A. So that's what the Hinge theorem says. The Hinge theorem says that if in a triangle, actually, let me flip to the next page. So we studied inequalities of one triangle, and the Hinge theorem is about inequalities of two triangles when we compare two triangles together. And it says that if I have two triangles, and if two sides of the triangles are congruent, see here? If these two are congruent, and if one angle is greater, so angle A is greater than the angle D, then I can draw the conclusion that their opposite sides, which is BC, has to be greater than EF, right? So again, if I have, in a triangle, I have two sides being congruent with their corresponding sides, and the included angle, A and D, if one is greater than the other, then the opposite side of the greater angle is longer than the opposite side of the smaller angle. And the converse is true as well, meaning if two sides are congruent and the third side is greater, so if I say BC is greater than EF, I'm sorry, it's not a segment, it's length. So BC is greater than EF, then I can draw the conclusion the included angle of the two congruent sides, angle A, is greater than the measure of angle D. Okay, so again, it's much easier thinking about the twin scenario than reading these words. The bottom line is that I have to have two sides being congruent, and then depends on whether the angle, the measure of the included angle, that determines the opposite sides of the two triangles. So let's look how we apply them. In example number 1, I have one side being congruent, I have a second side being congruent, and then the angle here are being different. So I would say KL is greater than PM. And in number 3, I have, let's see, I have 53 here, I have 93 here. So if I do 180 minus 32 minus 93, I can figure out that this one is 55. And therefore, and I'm asked about WX and XY. So in this case, I have one side being congruent. I have a shared side, so that's the second congruent side. And then the included angle is 53 and 55. So WX has to be less than XY because WX faces, is the opposite of the 53 degrees. Let's do a harder one with you. Let's see. Let's do number 5, which is about the converse. The converse says, now I'm given two triangles, all three sides, and I have one pair that's congruent. I have a second pair that's congruent. I have a third pair, and therefore angle D faces 35, so that's greater than angle H. And let's do number 7 and 8. 7 is I have one pair being congruent. I have a second pair being congruent. The third pair, this one is bigger. 14 is bigger. And therefore, I'm looking for RSQ. RSQ is facing 13, so that's less than the sides, that's the angle that faces 14, which is TQS. Number 8, again, one set being congruent, two pairs of congruent sides. Third side, 28 is bigger, so angle JMK is facing, is opposite of 27. That's the smaller side, so therefore that angle measure is less than angle measure of LMK. Okay, so as you can see, the application of Hinge theorem is not challenging at all. You do need to be able to identify two pairs of congruent sides and the included angle. So make sure you finish the packet and bring any questions you may have back to the classroom. Thank you guys. Take care.